All right, now let's talk about smart contracts. So what are they? Well, they are the building blocks of decentralized applications. And simply put, they are just programs that run on top of the blockchain. And they have many unique characteristics, which we'll explore in this lesson, that set them apart from regular programs. But let's just take a look at how they work. In order to understand how a smart contract works, let's compare it to how a different application works that you might be familiar with. So let's just think about a web application. All right, so if you use any modern website, it works like a sophisticated app. Let's say you're watching a video on youtube.com. It has multiple moving parts that works roughly like this, okay? So you are the user in this case, and you use your web browser, okay? And then with that web browser, you connect to the front end website, which you would see at youtube.com. That's what the front end is, the part the user sees, versus the back end, which is what they don't see, all right? And that front end website is, probably written something like HTML, CSS, and JavaScript, okay? And then that front end website talks to a back end, which is going to have a server, which contains all the code for the application. Maybe it's written in Python, JavaScript, PHP, or some other back end language. And that server talks to a database, okay, that stores all the user information. It stores anything that it needs, okay? So, this part is where all the business logic that runs the actual programs is stored in the back-end programming language, and then all the data for the application is stored inside this database. And this is all kind of in the same place, and this is all in its own place. So with a blockchain-based application, the back-end part is essentially replaced completely with the blockchain and smart contracts. So you can see an example here. Essentially, if you're going to use a blockchain-based application, in a really simple sense, you are a user and you use your wallet to connect with your web browser. Okay, so there's an extra step here. And then you connect to a blockchain-based website, which is still basically the same. It's just a website written in HTML, CSS, and JavaScript. That's the front end. Not too much changes here, but then the front end talks directly to a blockchain. So the back-end web server gets replaced in this case. And, the blockchain is the back end, and that's where the smart contracts go. So that's how they are programs that run on the blockchain. They're programs that developers create in a programming language called Solidity, and those all get compiled and deployed to the blockchain. So the blockchain is the environment where the smart contracts run. It's also the environment that replaces the database, because the blockchain fundamentally is a database in and of itself. So any data that's stored inside the smart contract gets written to the blockchain, and the smart contract is the execution environment for all those arbitrary programs that power the back end of this blockchain-based application. So why are they called smart contracts? Well, let's break that down. What is a contract? Well, a contract is an agreement or a covenant of some kind. And why are they called smart? Well, it's because they are digital programs. Computers run them, and they're digital versions of real-world agreements, hence smart contracts. And they're completely automated in this case because, they run on a blockchain. So they are really just digital representations of real-world contracts. So this goes to the idea that code is law. And you might see this running around in the blockchain space, and it's a popular mantra because that's sort of the ethos of smart contracts. You can create these digital agreements that represent real-world agreements and put them on the blockchain, and you know that the computer is a deterministic machine that's always going to enforce that agreement, and that you don't have to trust any type of intermediary, right? You don't have to trust a judge to enforce a contract in a certain way, all right, or someone to act to enforce the contract. The computer always enforces the contract, and you don't have to wonder whether it's going to work that way or not. So specific properties of smart contracts are that, of course, they are an agreement, a digital agreement, but one of the things that makes them so powerful is they are immutable, which means they cannot change. And this is what really makes them distinct from other programs. So, for the website that we saw a minute ago, like youtube.com, you don't necessarily know what, the website on youtube.com could change at any time, okay? A programmer could push, update to that, and the code could change. Now, with smart contracts, In their simplest form, a very simple smart contract, the code cannot change. That's what it means to be immutable. And that's a feature, not a bug. It's a design quality of smart contracts because you want the agreement to be set in stone. So once you put it on the blockchain, it's there forever. Now, there are some ways in which you can upgrade smart contracts with some design choices. We'll talk about some of those later. But for now, just understand that basic smart contracts, once you deploy the blockchain, they cannot change. And that's a feature because you would not want, someone to just randomly edit a real world contract. That's how you can trust them. So they're also transparent. So anyone who has access to the source code of the smart contract can see how it's written, and they can understand, exactly how it's going to work, or in other words, the terms of the contract at any given point in time. So if they want to participate in using it, then they can see how it's going to work, and it increases the trust in the actual smart contract itself. So another way of thinking about smart contracts is they're kind of like vending machines. So if you think about what does a vending machine do now, if you go up to it and you say, I want to buy a candy bar out of the vending machine, then it costs a certain amount of money, and you put the money in, you click a button, and it spits out a candy bar. And it's going to work the same way every time, of course, unless it gets stuck on a little hanger before it falls down. But smart contracts work the exact same way. So in many cases, they are having to do with financial transactions. So if you put money into a smart contract, it's going to give you something else in return, just like a vending machine. So a quick example might be a decentralized cryptocurrency exchange like Uniswap. All right. If you go to Uniswap and you put in one cryptocurrency, it's going to spit out a different cryptocurrency, just like a vending machine. And that's because it's powered by smart contracts. All right. So one really important property of smart contracts that you have to understand is that they enable complex transactions. So smart contracts on Ethereum, were one of the first really important innovations that took it beyond Bitcoin, because now you could do really sophisticated things with the blockchain. So for example, with Bitcoin, basically all you can do is send cryptocurrency around from one account to another. It has some scripting capabilities, but essentially that's really what it does. Now with Ethereum, of course, you can send cryptocurrency around, but you can also perform complex transactions. And that's really what smart contracts are for. So let me show you what I mean by that. So again, a blockchain is just a public ledger full of transactions. So anytime you do something on the blockchain, you are creating a transaction and it's getting added to the blockchain. So remember, all these transactions are grouped together in bundles of records called blocks, which are chained together to make the blockchain. So an example of a simple transaction like I was just talking about is sending cryptocurrency around. So let's do this on the Ethereum blockchain, for example. Let's just say that I just want to send cryptocurrency from my account to yours. So this is going to be 1 Ether. So this is a simple transaction. It really only has one step: send Ether from my account to yours. Now you could call this 2 steps, which would be, take it out of my account and add it to your account. But the whole idea is, this is abstracted into a single instruction that the blockchain understands by default. You just have to tell it to do that, right? But the great thing about smart contracts is that they open up the door to create complex transactions that have multiple steps, and you can make the steps whatever you want. That's the beauty of being a programmer, is you can write these arbitrary contracts that perform multiple steps in each transaction. So here's an example. Let's take a real world smart contract like a decentralized exchange. So Uniswap is a good example of this, where you can swap tokens on a website directly with a smart contract. It works like a vending machine that way. You can just say, I have this cryptocurrency and I want to swap it for a different one. So in this example, we're just going to say I have Ether, right? Native cryptocurrency, Ethereum blockchain, and I want to swap it for a stable coin, which is called USDC. Okay. So when you talk to Uniswap and you call that smart contract, underneath the hood, it's creating a very complex transaction that the blockchain does not natively understand. So a programmer had to write a smart contract that performs this complex transaction with multiple steps. So like step 1, just from a high level, might be take ETH out of my account. All right. Step 2 would be credit ETH to the contract. All right. Step 3 might be take USDC out of the contract. And then 4, credit USDC to the account. And then step 5 might be deduct any trading fees that are associated with this. And so again, you can maybe group these in the same step in these, but still, it's multiple steps the blockchain does not natively understand. And that's what smart contracts allow you to do. So when you're a programmer, you are writing functions inside the smart contract that have multiple lines, and each line in that function typically represents a different step in each transaction. And we're going to see that as we start coding out smart contracts in future videos, but that's essentially why they're powerful and how they manipulate the blockchain with code. The smart contracts are written primarily in the Solidity programming language when you are creating contracts for Ethereum and other EVM-compatible blockchains and layer 2s. So Solidity is an object-oriented high-level language. It looks, somewhat like Python, C++, and JavaScript. So if you're familiar with any of these languages, then, you're going to have a big leg up at learning Solidity. The other thing is if you don't know these languages already, that's okay, because these languages are relatively easy to learn on the grand scheme of things, which means that Solidity shares these properties, okay? So there are other programming languages used to write smart contracts like Viper, for example, but a vast majority of smart contracts that are written for Ethereum and other EVM-compatible chains are implemented in Solidity. You can just go look on GitHub at any of the open source projects to verify that type of thing. We're going to dive into coding Solidity in an intro video in the future, and then extensively when we start creating the Capstone project, but I want to just make that quick mention of that in this video. Okay, so one more thing I want to mention about smart contracts and their properties. So really, a smart contract is the building block for a decentralized application. I mentioned that at the beginning of this lesson. And so sometimes you have smart contracts that are really just one file, one smart contract that stands on its own and doesn't really talk to any other smart contracts. That's a simple example. And there are real world blockchain-based applications that exist like that. But many more sophisticated blockchain-based applications have multiple smart contracts that all talk to one another, much like classes within a complex object-oriented program. You have classes as the fundamental unit for building those, and you have multiple classes that talk to one another that maybe talk to a database, okay? Or like a functional programming system, you have these functions where you encapsulate the code, the business logic, as the smallest unit of account for that, system. So in a very similar way, smart contracts are the smallest unit that you use to talk to other smart contracts in that system to make a complex program. Let's talk about some real-world examples of smart contracts. So first and foremost, tokens are a smart contract. Okay, we'll look at some of those here in a second. So these are cryptocurrencies that exist on top of another blockchain powered by smart contracts. That's one of the beauties of Ethereum and other EVM-compatible chains is you can create your own cryptocurrency without creating your own blockchain with smart contracts. And so you can create smart contracts for tokens that are, like a digital agreement. You want a money to work the same way every time. Anytime you send cryptocurrency around, you want to make sure that it works the same way every time and cannot change. That's why you use a smart contract for this and not some sort of centralized database and program. So non-fungible tokens are a popular example, or NFTs. All right, so there's lots of things you can do with non-fungible tokens or NFTs. One of the most popular use cases are digital collectibles. So we want to use smart contracts for these because we don't want the code to the NFT to change. All right, we want it to be a digital agreement that I own this, and if I send it to somebody else, that it's going to transfer the ownership, and that it's going to live forever on the blockchain. So another example of a popular decentralized application is a decentralized cryptocurrency exchange like Uniswap, for example. If you go to Uniswap and you click swap on a token, you know that it's going to dispense tokens out of the vending machine to your account, and it's going to take your money, and that it's a digital contract that works just like that. And there's so many more examples, but these are some of the top ones that I want to illustrate, how they work. And so we can look at some quick examples of those in the wild. So as far as tokens go, we can look at a stable coin like USDC or USDC coin. That's the example I used previously when we were swapping on Uniswap. And you can see the transactions. They all have this transfer function. This is for the actual smart contract. And if you go to the contract page, you can see the source code for the contract. Okay, so if we actually just go here, let's look at the contract page and click contract here. Then we can see the Solidity source code. All right, And you can see that it has multiple files, all right, that all talk to one another, okay? That this is actually going to reference other files rather than just this one. We'll see a better example of that with Uniswap here in a second. All right, so another one are NFTs, like I was saying before. And so you can see, this is an example of a Bored Ape Yacht Club. This is a really popular digital collectible. And if you go to Etherscan, you can see that it has, a contract here. All right. And you can see the Solidity source code. All right, here. And it's got multiple contracts, all the same files. You can see an interface that's talking to a different contract. You can see an interface talking to a different contract here. If you go all the way to the bottom, you'll find the beginning. Yeah, contract Bored Ape Yacht Club is ERCF 721 is ownable. All right. So, this is an example of an NFT contract. And then finally, we can look at Uniswap version 3. This is the actual router. Okay, so this is, the smart contract that powers this particular blockchain-based application, and you can see multiple files are broken out here. It's a much more organized deployment. And so this is great. It's transparent. You can get in here if somebody has the ability to audit the code. They can see how it works. It's pretty complex. The average user is not going to be able to see how it works, but it's still transparent. And, a third party who is trained could verify how this works. And that's a big paradigm shift from a closed source application that's a black box that nobody understands. All right. So you don't have to trust a centralized entity to understand how the code works. Anybody with the skills can go out and see this. And so earlier when I was talking about how, blockchains support complex transactions, and that's what you do as a programmer, then we can just look at some of the transactions here on Uniswap to see how they perform multiple steps. So I'm literally just going to look at, one of these transactions. And here you go. Here's what a swap looks like on Uniswap. There's 2 steps, really. Swap USDT for USDC, and then swap USDC for Ether. Okay. And you can see all the steps that are performed in this process. 1, 2, 3, 4 different token transfers. And that's, a complex transaction, multiple steps that the blockchain does not understand by default. A programmer has to get in and write a smart contract that does all this to actually create the vending machine. All right, so that's the introduction to smart contracts from a conceptual high level. Again, we're going to have a separate video that's going to give you the introduction to the coding for smart contracts, but I wanted to give you this conceptual framework so that you can understand what you're doing when you get into that. And then also, we're quickly going to get into the depths of smart contract programming in the capstone section. So until then, I'll catch you in the next video.